Suppose a hyperbola is positioned in such a way that its center is at the origin of the coordinate system and the foci are on the x-axis. We will develop here the equation of such hyperbola. Let's first notice that the transverse axis is the axis going through the foci and the center, and the vertices are also on that axis, and the conjugate axis is going to be y-axis. So we know that the center is positioned at the point 0, 0. We also know from the discussion of a hyperbola that the distance between the center and the vertex is a, the number that appears in the definition of a hyperbola. And therefore, this tells me that vertex v sub 1 has coordinate a, 0, and the vertex v sub 2 has coordinates negative a, 0. And a here is the distance between the center and a vertex. Now let's define the value of C to be the distance between the center and a focus. So the distance here is the C, and on the other side, due to the symmetry, the other distance is also C. And therefore, we can say that the foci have coordinates C, 0 and negative C, 0. Now let P be any point on the hyperbola, and let's say P has coordinates x and y. We want to obtain the equation that describes the relationship between x and y for any point on that hyperbola. We start with the definition of the hyperbola that says that it is a set of points P such that the distance d sub 1 minus d sub 2 in absolute value is equal to a. If we eliminate absolute value, that equation means that d1 minus d2 is plus or minus 2a. And translating to the distances, we can write that this is the distance between P and F sub 1 minus distance between P and F sub 2, and this distance is to be 2a. Because we have in the coordinate system distance formula, each of those distances can be expressed as the radical difference of the first coordinates squared plus difference of the second coordinates squared minus the other distance is going to be difference of the x coordinates, so this is x minus minus c, so it's going to be x plus c squared plus the difference of the y coordinates, and this is going to be plus or minus to a, depending on the position of the point P. Now, when we work with this expression, when we want to simplify, we would have to isolate a radical, square both sides, and simplify, and do it all over again. So after doing a lot of work that you can see the details in the textbook or in the notes, we would end up with the equation c squared minus a squared times x squared minus a squared y squared equals a squared c squared minus a squared. Because we know that the c value is more than the a value, this was our choosing of value a, c squared is going to be more than a squared, and therefore expression c squared minus x squared is positive, and therefore we'll define a number b, a positive number b, in such a way that b squared is going to be c squared minus a squared. And if we choose to replace c squared minus a squared by b squared and divide now both sides of that equation by a squared times b squared and simplify, the process that we did using the equation of the ellipse will end up with x squared over a squared minus y squared over b squared is equal 1. This is the standard equation of a hyperbola with center at the origin and the foci on the x-axis. To see the relationship between A, B, and C, please watch the subsequent video.